Take a deep, slow breath and let your body settle completely into the comforting embrace of the space around you. We are leaving the bounds of Earth tonight, slipping the bonds of gravity and journeying effortlessly into the majestic, silent heart of the Eagle Nebula. Catalogued by astronomers as Messier 16 or M16, this immense stellar nursery rests peacefully roughly 7,000 light-years away from our home planet. Consider the profound nature of this distance for a moment. The gentle light you are about to observe began its long, quiet journey across the cosmic void before recorded human history even began, traveling through the dark to finally reach your eyes tonight. As we drift smoothly into the constellation Serpens, the darkness around you begins to bloom with deep, muted colors. Within this celestial sea lies a magnificent structure you might already know: the Pillars of Creation. First captured in breathtaking detail by the Hubble Space Telescope in 1995, these towering clouds of gas have become an icon of the universe's quiet beauty. Imagine floating weightlessly beside these colossal, shadowy towers. The tallest of these pillars stretches an unfathomable 4 to 5 light-years in length. To truly sense that scale, consider that a single light-year is nearly 6 trillion miles. This single billowing column of dust is actually larger than the distance from our sun to its nearest neighboring star. Yet, despite its massive size, it appears incredibly delicate, like wisps of smoke suspended in a vast, motionless room. As you drift closer to the pillars, try to sense the profound, preserving chill of this cosmic nursery. You might wonder what a cloud in space feels like. These pillars are composed primarily of cold molecular hydrogen gas and fine, microscopic silicate dust. The temperature here is a staggering 10 to 20 Kelvin, which translates to roughly minus 440 degrees Fahrenheit or minus 260 degrees Celsius. It is a deep, absolute cold. It is a tranquil stillness where the raw elemental materials of the universe wait patiently, gathering in the dark to be ignited into something new. Surrounding you, the void is painted in a silent symphony of color, mapped by the specific elements drifting through the vacuum. In the famous Hubble palette, a way astronomers translate invisible wavelengths into colors we can see, sulfur emissions glow in a soft, warm red. Hydrogen radiates a soothing, luminous green, and oxygen washes the edges in a tranquil, ethereal blue. Imagine swimming through this ocean of glowing mist, the velvet dark of space illuminated by gentle ribbons of ruby, emerald, and sapphire. Though it looks perfectly still, you can almost feel a gentle, invisible pressure against you here. This is the stellar wind. Intense ultraviolet radiation pours outward from a cluster of massive, incredibly hot O-type stars located just above the pillars. Some of these brilliant young giants hold up to 80 times the mass of our own sun. Their fierce, invisible light acts like a cosmic sculptor, physically eroding and carving the cold dust into the majestic, finger-like spires you see before you. This open star cluster, officially designated as NGC 6611, is the engine of the nebula. In cosmic terms, it is merely a toddler, you estimate it to be only 1 to 2 million years old. Yet, it commands the space around it with a silent, radiant authority. You can imagine the warmth of their distant light brushing against your skin, an imperceptible push that dictates the shape of the entire nebula. Floating along the textured, shadowy edges of the pillars, you might notice small, glowing protrusions reaching out into the void. These fascinating structures are known in astrophysics as EGGs, an acronym for evaporating gaseous globules. Here is something remarkable to ponder. Some of these tiny finger-like bumps on the edge of the pillar are actually larger than our entire solar system. Inside these dense, dark pockets of gas, gravitational forces are gently, slowly pulling matter together. The pressure builds in perfect silence, warming the core until a brand new star is born. You are floating through a nursery of suns, watching the slow, rhythmic clockwork of creation. Let your awareness expand outward, beyond the famous pillars. The entire Eagle Nebula is a vast, sprawling cloud, spanning an area of roughly 70 by 55 light-years. When it was first discovered by the Swiss astronomer Jean-Philippe Lois de Chezeaux in the year 1745, he could only see the faint, glowing star cluster through his telescope. He could never have imagined the profound microscopic details you are floating among right now. The intricate tapestry of gas and dust that weaves between the stars. As you glide effortlessly through the velvet dark, you approach the eastern side of the nebula, encountering another breathtaking formation known as the stellar spire. This solitary monument of dust reaches 9.5 light-years long, nearly double the length of the tallest pillar of creation. It stands like a quiet sentinel in the dark, a soft, towering mountain of cosmic clay. There is a deeply comforting feeling in the presence of such massive, unmoving structures. They do not rush. They do not hurry. They simply exist, transforming at a pace so gradual, it feels like eternal stillness. There is a beautiful, poetic balance to this environment. The process creating these shapes is known as photoevaporation. The very stars that were born from this dust, the ones shining so brightly above, are now slowly, steadily blowing the dust away. It is a gentle reminder of the universe's cycle of creation and return. The stars borrow the dust to burn, and their light eventually scatters the remaining dust back into the void, seeding the galaxy with new elements. It is a slow, rhythmic exhalation of the cosmos. Recently, humanity looked at this comforting space with an entirely new set of eyes. In 2022, the James Webb Space Telescope peered into the Eagle Nebula using near-infrared light. Infrared light is special because it pierces right through the thick, obscuring dust. Imagine donning a pair of glasses that suddenly turns the shadowy, opaque dust into translucent, softly glowing glass. Through this lens, thousands of nascent glowing red stars were revealed, stars that were previously hidden deep within the dark pillars. The dusty towers transformed into a glittering treasure chest of newborn suns, scattered like warm embers against the dark. If your senses could shift once more to perceive X-rays, the view would change again. The Chandra X-ray Observatory spent time staring into this nursery and detected hundreds of young stars emitting intense X-rays. While completely invisible to the human eye, you might imagine this energy as a subtle, rhythmic hum, a deep, resonant vibration pulsing through the vacuum of space. It is the heartbeat of infant stars, settling into the lifelong rhythms that will carry them through billions of years of existence. There is even a grand, sweeping mystery floating through this serene space. In 2007, the Spitzer Space Telescope detected a massive, expanding cloud of hot dust sweeping through the region. This particular signature of heat led scientists to theorize that a supernova, an incredibly powerful exploding star, might have actually destroyed the pillars of creation roughly 6,000 years ago. Because light takes 7,000 years to reach us, the light of that destruction simply hasn't arrived at Earth yet. It is a deeply peaceful, humbling thought. As you float here, marveling at the towering structures of hydrogen and dust, you may be observing beautiful cosmic ghosts. You are bearing witness to a quiet majesty that time has already reclaimed. The stars are a time machine, and the beauty you see is a frozen memory of the universe offered to you as a gift in the present moment. Allow yourself to drift through this glowing memory. Feel the profound emptiness of the vacuum supporting you, a weightless sanctuary where you are completely safe. The colors wash over you, the warm reds of sulfur, the soothing greens of hydrogen, the deep blues of oxygen. The temperature is impossibly cold, yet you feel only a comforting, insulated warmth within your own consciousness. The stellar winds brush past, silent and unseen, while the great pillars of dust stand as monuments to the slow, beautiful patience of physics. There is no rush here. Gravity takes millions of years to pull a star together. The universe operates on a timescale so vast, so incredibly forgiving, that the anxieties of a single day dissolve into the gentle hum of the cosmos. As you glide further into the glowing mist, the intricacies of the Eagle Nebula surround you, inviting you deeper into the slow, endless dance of space. We shift our gaze now, stepping back from the towering silhouettes to appreciate how humanity slowly, patiently untangled the mysteries of this serene cosmic sanctuary. The evolution of our understanding is much like deciphering an ancient, time-worn manuscript. Early stargazers could only read the boldest, brightest letters, the radiant stars themselves. It took generations of quiet observation and technological evolution to finally perceive the delicate fading ink of the gas clouds that form the margins of this celestial page. On the serene night of June 3rd, 1764, a French astronomer named Charles Messier stood in the cool air of Paris, meticulously recording a cluster of stars in his notebook. He formally designated this gathering of light as number 16 in his now famous astronomical catalog. Messier was, in truth, a dedicated comet hunter. To his eyes, the hazy, unmoving patches in the night sky were merely static, gentle distractions in the background of his search for wandering ice. His telescope, an instrument crafted with the finest optics of the 18th century, featured an aperture of roughly 3.5 inches. Through that small glass lens, he could only resolve the brightest, most piercing members of the central star cluster. The colossal, billowing curtains of stardust that we know so well today remained entirely invisible to him, waiting silently in the dark. Decades drifted by, and in the mid-19th century, the tools of observation grew far more ambitious. In Ireland, William Parsons, the third Earl of Ross, pointed a magnificent towering telescope toward the constellation Serpens. Known affectionately as the Leviathan of Parsonstown, this groundbreaking instrument boasted a massive 72-inch speculum metal mirror. The mirror was so heavy and required such exhaustive polishing that it represented a true labor of love. With this light-gathering giant, humanity finally collected enough ancient photons to glimpse the darker, sweeping lanes of dust surrounding the brilliant cluster. The arrangement of these dark silhouettes against the glowing backdrop stirred the imagination. Early stargazers believed the shape resembled a massive bird in mid-flight, visualizing great, outstretched wings spanning the silent void. From these quiet, earthbound observations, the enduring moniker of the Eagle Nebula was born. Picture this immense avian shape stretching across the canvas of the sky. From our solitary vantage point on Earth, the entire Eagle Nebula covers an angular area of about 30 arc minutes. This measurement holds a beautiful, familiar context. If the faint, glowing gases were just bright enough for our unaided human eyes to perceive in the night sky, the nebula would appear almost exactly the same size as the full moon. It sits above us every summer night, a massive hidden phantom watching over the sleeping world. The true leap in our cosmic literacy occurred with the quiet magic of astrophotography. In the year 1895, the pioneering astronomer E. Barnard aimed his photographic plates at this very region. Shortly after, in 1897, another dedicated observer named Isaac Roberts utilized a 20-inch reflecting telescope to capture prolonged, uninterrupted exposures. For the first time in history, human eyes did not have to rely on fleeting, shivering glimpses through a glass eyepiece. The photographic plates were able to stare unblinking into the deep dark, patiently collecting light over many hours. These early silver emulsion plates permanently etched the complex, wispy architecture of the nebula into the scientific record. What those photographic plates were actually capturing is a beautiful, rhythmic phenomenon happening at the microscopic level. Scientists classify the Eagle Nebula as an H2 region. This designation means it is a sprawling domain of ionized hydrogen gas. Deep within the nebula, outside the cold, protective dust of the pillars, the ambient temperature of this energized gas reaches a blistering 10,000 Kelvin. Yet, because the vacuum of space is so incredibly sparse, you would not feel this heat as a burning fire, but rather as a highly charged, gentle energy field. At this very moment, a microscopic ballet is unfolding all around you. Countless electrons are being gently stripped away from their hydrogen protons by the fierce radiation of the nearby stars. Eventually, a wandering electron feels the quiet pull of a proton and recombines with it, dropping back down to a state of rest. As the electron settles down, it releases a tiny singular packet of energy, a photon. Scientists have measured the precise wavelength of this settling light. It registers at exactly 656.28 nanometers. In the language of quantum physics, this highly specific measurement is known as the hydrogen alpha line. To the human eye, light arriving at 656.28 nanometers registers as a profound, rich, and vibrant crimson. While modern space telescopes often translate invisible light into various artificial hues to map different elements, the true visible color of the Eagle Nebula is a deep, glowing magenta red. Imagine drifting through a warm crimson tide, an endless ocean of red light rolling quietly through the cold vacuum. The light is perfectly steady, an unbroken glow, generated by trillions upon trillions of atoms resting and releasing their energy in perfect eternal rhythm. Consider the driving force behind this glowing red sea, the central star cluster. Modern surveys, mapping the dark with incredible precision, have counted approximately 8,100 individual stars bound together in this stellar family. They move together through the galaxy, a slow, majestic migration of young suns. The brightest and most dominant member of this cluster is a fascinating entity, designated as HD 168076. This is not a solitary body, but a binary star system. Two massive, incredibly luminous celestial spheres locked in a perpetual, swirling embrace. They orbit one another in a slow, graceful waltz, their combined gravity anchoring the space around them. Despite its massive output of light and energy, HD 168076 possesses an apparent magnitude of 8.24. Because the threshold for naked eye visibility on Earth is a magnitude of roughly 6.5, This powerful system remains a hidden gem, requiring binoculars or a telescope to be plucked from the comforting darkness. By observing the temperature and luminosity of these 8,100 stars, astrophysicists can plot them on a specialized graph called the Hertzsprung-Russell diagram. This mathematical tool acts like a cosmic clock, allowing researchers to accurately calculate the age of the cluster. The oldest glowing inhabitants in this nursery ignited into existence roughly 5.5 million years ago. In the grand, sweeping calendar of the universe, where galaxies take billions of years to mature, these stars were born only moments ago. They are shining with the steady, calm vitality of absolute youth. Notice how this quiet nursery fits perfectly within the larger, grander architecture of our galaxy. The Milky Way is a barred spiral galaxy, patterned with great curving bands of gas and starlight that spiral outward from a brilliant center. Our own solar system floats gently within a minor, relatively quiet branch called the Orion Spur. The Eagle Nebula, however, sits further inward, resting securely within the massive neighboring structure known as the Sagittarius Arm. When you cast your gaze toward the Eagle Nebula, you are peering directly into the thicker, more densely populated inner lanes of our galactic home. It is a region brimming with cosmic potential. To understand just how much potential resides here, scientists in the mid-20th century turned to radio astronomy. Rather than looking for visible light, they tuned their instruments to listen for the faint frequencies of carbon monoxide molecules interwoven through the dark dust. These radio measurements provided a way to weigh the invisible. The results revealed an astonishing truth. The star-forming material still lingering in this region contains over 10,000 times the mass of our own sun. It is a tranquil reservoir of unimaginable scale, where the raw ingredients for 10,000 new solar systems are simply drifting here, suspended in the cold vacuum, waiting for gravity to begin its slow, methodical work. There is no urgency in this cloud. The speed of light remains a constant, unwavering 299,792 kilometers per second, carrying the glow of the hydrogen alpha emissions across the void at a perfect, unchanging pace. As you float within the quiet current of the Sagittarius Arm, you can sense the profound patience of the universe. The gas slowly gathers. The electrons quietly settle. The ancient photons make their steady journey across millennia, eventually landing softly on the silver plates of our early telescopes, offering humanity a glimpse into the boundless beauty of the dark. Embrace the slow, rhythmic certainty of these cosmic laws, completely insulated in the calm, unhurried expanse of space. As we continue to navigate the quiet currents of the inner galaxy, it is tempting to look at the thick, opaque silhouettes of the pillars of creation and imagine them as objects, as solid as stone, or perhaps as dense as storm clouds on Earth. The visual illusion is incredibly convincing, yet the physical reality of this environment is breathtakingly sparse, offering a lesson in the beautiful deception of cosmic scales. Think of a faint morning mist suspended over a calm, glassy lake. Up close, the mist is nothing more than scattered, invisible droplets of moisture. You can wave your hand right through it without feeling a thing. But when observed from a distance, stacked across miles of space, that same mist builds into an impenetrable solid wall of white. The Eagle Nebula operates on this exact same principle, but on a scale that defies earthly comparison. A single cubic centimeter of air in the quiet room where you are resting contains roughly 25 quintillion microscopic molecules. By contrast, a cubic centimeter within the absolute densest core of the Eagle Nebula's pillars holds only about 1,000 to 10,000 particles. This means the towering, mountainous cosmic clouds are actually a vacuum, far more perfect and empty than anything we could ever artificially create in a laboratory on Earth. If you were to somehow gather all the floating material from a space the size of an average home within this nebula, it would barely weigh as much as a single fine grain of beach sand. Reflect on the profound peacefulness of that emptiness. You are floating through a structure that is almost entirely made of nothing, yet it casts shadows across light years. What exactly is this sparse, shadowy material composed of? When astronomers analyzed the infrared signatures of the dust using the Spitzer Space Telescope, they detected a rich abundance of complex molecules known as polycyclic aromatic hydrocarbons, or PAHs. These are carbon-based compounds, and they are something you are actually very intimately familiar with. On our home planet, PAHs are the exact same molecules found in the dark soot of a crackling campfire, the blackened char on a piece of burnt toast, or the exhaust from an everyday vehicle. Here, in the Eagle Nebula, these tiny flakes of carbon drift endlessly, unburned and ancient, floating in perfect silence. Observe the microscopic nature of this cosmic soot. Each individual dust grain measures a mere 0.1 micrometers across. This makes them hundreds of times thinner than a single strand of human hair. Deep inside the darkest, most sheltered pockets of the cloud, where the ambient temperature plummets to a staggering 10 Kelvin, these tiny carbon grains act as microscopic seeds. Stray oxygen and hydrogen atoms bond directly to their microscopic surfaces, freezing instantly in the deep chill to form delicate crystalline mantles of pure water ice. Even here, billions of miles from any ocean, the fundamental ingredients for frozen water quietly assemble in the dark. There is an invisible protective architecture holding these delicate icy clouds together. In 2018, using the highly sensitive instruments of the James Clerk Maxwell Telescope, located on the dormant volcano of Mauna Kea in Hawaii, whose scientists successfully mapped the magnetic fields threading through the pillars of creation. They discovered something mesmerizing. The magnetic field lines run perfectly parallel to the vertical length of the pillars. This magnetic skeleton acts like unseen structural scaffolding. The strength of this field ranges from 100 to 300 microgauss. To put that precise measurement into a familiar context, the gentle magnetic pull of our own Earth, the force that reliably guides compass needles north, is about 500,000 microgauss. Furthermore, a standard magnet holding a photograph to your kitchen refrigerator is millions of times stronger than the field winding through the nebula. Yet, across trillions of miles of near-empty space, this incredibly delicate, whispering magnetic framework is just enough to guide the flow of the gas. It maintains the pillar's majestic, upright posture against the chaotic forces of the surrounding void, like an invisible hand gently holding a ribbon in the wind. Focus your attention on the forces interacting with this magnetic ribbon. The primary sculptor of this entire environment is a massive, intensely hot star, formally cataloged as an O6.5V type. This brilliant stellar giant blasts out supersonic winds of radiation at speeds reaching between 1,000 and 3,000 kilometers per second. If you could travel at 3,000 kilometers per second on Earth, you could smoothly cross the entire Atlantic Ocean in under 2 seconds. These incredibly fast stellar winds act much like a gentle, relentless tide against a fragile sandcastle. Precision measurements show that the pillars are currently losing mass at a rate of roughly 70 solar masses every single million years. One solar mass is equal to the entire weight of our Sun, which itself is about 330,000 times heavier than the Earth. Despite this constant sweeping erosion from the O6.5 Vi star, the sheer volume of the dust structure guarantees it will persist for another 3 million years before finally dispersing into the interstellar medium. It is a slow-motion vanishing act, unfolding at a pace so impossibly gradual, it feels entirely motionless. There is a deep comfort in this time frame. The stars do not rush. The dust does not hurry. The universe gracefully takes millions of years to reshape its art. At the very tips of these slowly evaporating pillars, you will find the dense protective knots of gas, known as EGGs. Inside these tiny shielded nodules, the material is highly concentrated and safe from the stellar winds. Researchers calculate that a single one of these globules contains roughly 10 to 60 times the mass of the planet Jupiter. Deep within these dark, heavy shells, protoplanetary disks, occasionally called proplids, begin to take their familiar shape. These are flat, swirling halos of ancient dust and gas, measuring about 100 astronomical units across. 1 astronomical unit is the exact distance between the Earth and the Sun, approximately 93 million miles. Therefore, a 100 astronomical unit disk is large enough to encompass our entire solar system outward, far past the distant orbit of Pluto. All of this material is slowly spinning together, like a perfectly balanced cosmic record player. It is a silent, elegant rotation that will eventually coalesce into rocky planets, gas giants, and perhaps billions of years from now, calm oceans under new skies. Shifting our view slightly beyond the dark dust, the surrounding ionized gas offers its own calming, luminous palette. Earlier, we observed the warm crimson glow of hydrogen, but there is another highly distinct chemical signature painting this celestial canvas. Doubly ionized oxygen, referred to by astrophysicists as oxygen-3, emits a very specific steady wavelength of light. When an oxygen atom loses 2 electrons to the surrounding radiation and eventually recaptures 1, it releases a photon that measures exactly 500.7 nanometers. When this highly precise wavelength of light travels across the galaxy and meets a human eye, or a telescope sensor, it registers as a brilliant, soothing teal or a soft blue-green. You might easily recognize this exact shade of glowing gas from your life on Earth. It is the very same physical principle utilized in earthly neon signs that softly illuminate quiet city storefronts at midnight. Just as an electrical current runs continuously through a glass tube to excite trapped neon gas into a warm, buzzing glow, the intense ultraviolet radiation from the young stars electrifies the oxygen suspended in space. The result is a massive teal-colored nightlight cast across dozens of light years. Float within this tranquil, blue-green illumination. The vacuum remains a perfect insulator, meaning none of the physical heat from these interactions reaches you. You are simply suspended in a grand, silent laboratory of physics, where carbon soot identical to campfire ash forms frozen ice crystals in a magnetic cradle, where winds traveling thousands of kilometers a second gently carve shapes that will outlast our own civilization. It is a perfectly balanced system, a cosmic clockwork, spinning effortlessly in the dark, inviting you to simply observe its serene, mechanical beauty. Let us journey further into the mechanics of this silent nursery, shifting our attention from the towering columns of dust to the specific life cycle of the stars being born within them. What is happening now is a profoundly beautiful translation of energy, an ancient process that intimately links the cold depths of the Eagle Nebula to the very existence of life on Earth. Deep inside the dark, protective EGGs we observed earlier, gravitational collapse is reaching a critical threshold. As the hydrogen gas compresses tightly together, friction naturally begins to build. The core of this collapsing knot of gas slowly climbs in temperature, eventually hitting roughly 15 million degrees Celsius. At this precise thermal tipping point, a fundamental physical threshold is crossed. Nuclear fusion ignites. This ignition marks the birth of a main sequence star. For a star like our Sun, this steady, reliable phase of burning hydrogen into helium will last for approximately 10 billion years. When you look at the young, brilliant stars scattered throughout the NGC 6611 cluster, you are observing them in their absolute infancy. Because these massive O-type stars are burning through their hydrogen fuel at an incredibly furious rate. Their lifespans are actually much shorter than our Sun's, destined to last only a few million years before exhausting their core reserves. This concept might seem counterintuitive, that the largest, brightest fires burn out the fastest. Think of a massive roaring bonfire built with dry pine. It flares up brilliantly, casting light far into the woods, but it reduces to ash in a matter of hours. Conversely, a single dense lump of slow-burning coal will sit quietly in a hearth, radiating a steady, comforting warmth for an entire night. Our Sun is the slow-burning coal, offering a steady, dependable heat that allowed billions of years for oceans to settle and biology to take root on our world. Scientists have deeply studied the chemical composition of the star-forming regions in the Eagle Nebula, specifically measuring an astrophysical concept known as metallicity. In the strict terminology of astronomers, any element heavier than helium is classified as a metal. Using spectrographic analysis, splitting the starlight into its component colors like a prism, researchers found that the metallicity of the Eagle Nebula is remarkably similar to that of our own solar system. The significance of this chemical similarity cannot be overstated. It means that the gas and dust floating around you right now possess the exact same ratio of heavy elements, carbon, nitrogen, oxygen, and iron, that was present in the cloud that birthed our own Sun 4.6 billion years ago. You are not just looking at a random assortment of cosmic dust. You are looking at a chemical mirror. The ingredients suspended here are the exact recipe required to eventually build rocky mantles, metallic planetary cores, and the fundamental building blocks of cellular biology. Notice how the mechanics of the nebula ensure these vital elements are eventually shared. The massive stars in this cluster, due to their immense weight and rapid fusion rates, are destined to end their lives in spectacular fashion as Type II supernovae. When a star with at least 8 times the mass of the Sun completely runs out of fuel, its core violently collapses inward under its own crushing gravity, creating a rebound explosion of unimaginable force. While this sounds like a chaotic event, it is actually the most generous act in the cosmos. During the final fraction of a second of a supernova explosion, the temperatures spike so high that entirely new elements are forged. Every single atom of gold, silver, uranium, and iodine in the universe was created in the instantaneous flash of a dying star. The ensuing shockwave then sweeps through the surrounding space at roughly 30,000 kilometers per second, carrying these newly forged heavy elements with it. This shockwave eventually slams into nearby cold molecular clouds. much like the ones making up the pillars of creation. The impact gently compresses the cold gas, acting as a gravitational trigger that sparks the collapse of new pockets of dust, setting the stage for the next generation of stars to be born. It is an elegant, perpetual cycle of cosmic recycling. A star dies, enriching the void with heavy elements, and the force of its passing pushes the dust together to birth new suns, which now contain the gold and iron forged by their predecessor. The iron coursing through your bloodstream right now, binding to oxygen and giving your blood its red color, was forged in the core of a massive star that lived and died billions of years before the Earth even existed. By observing the Eagle Nebula, you are watching the exact process that manufactured the materials making up your own body. To map this complex exchange of materials, astronomers rely on highly specialized tools like the Atacama Large Millimeter/Submillimeter Array, or ALMA. Located high in the arid, breathless environment of the Chilean Andes, ALMA consists of 66 massive radio antennas working in perfect unison. In 2020, ALMA was used to peer into the Eagle Nebula to observe the specific thermal emissions of carbon monoxide gas. ALMA's observations revealed a network of intricate, thread-like structures called filaments, weaving through the darker, colder regions of the cloud. These filaments act like celestial highways, funneling cold gas directly from the outer fringes of the nebula straight into the dense cores where the protostars are forming. Gravity acts as the quiet engine driving this flow. The matter moves slowly, traveling at merely a few kilometers per second, a gentle, steady trickle of sustenance feeding the newborn stars. You can imagine these filaments as the roots of a great tree, drawing water from the surrounding soil to nourish the growing branches above. It is a slow, methodical gathering of resources, dictated by the unwavering, predictable pull of mass. Everything is connected in a delicate, balanced web of gravitational influence. Consider a subtle, secondary effect of this star formation: the emission of Herbig-Haro objects. When a newborn protostar is actively feeding on the gas from its surrounding accretion disk, it occasionally ingests material too quickly. To stabilize its rotation and manage this excess energy, the young star fires off twin, highly focused jets of superheated plasma from its north and south poles. These narrow beams of energy shoot out into the surrounding dark, traveling at blistering speeds of hundreds of kilometers per second. When these high-speed plasma jets finally crash into the cold, stationary gas of the nebula, they create bright, glowing shockwaves known as Herbig-Haro objects. Several of these glowing bow shock formations have been identified deep within the Eagle Nebula, specifically labeled as HH216 and HH217. When these glowing shockwaves are relatively fleeting on cosmic timescales, lasting only a few thousand years before fading away. They are the temporary energetic footprints of a star taking its first true breaths. Observing a Herbig-Haro object is like catching the brief bright spark of a flint just before the campfire catches. It is a rare, transient phenomenon that highlights the dynamic, ever-changing nature of what otherwise appears to be a perfectly still landscape. As you float peacefully among these ancient processes, acknowledge the deep intrinsic connection between the quiet mechanics of this distant cloud and your own existence. The gravitational collapse gathering the dust, the nuclear fusion igniting the dark, and the eventual dispersion of heavy elements into the void are not isolated, distant events, when they are the prerequisite steps for solid ground, deep oceans, and the steady, comforting beat of a human heart. The universe is slowly, meticulously weaving the tapestry of reality, taking millions of years to perfect a single thread. You are entirely safe in this unhurried environment, held securely by the vast distances and the perfect insulation of the vacuum. The silent clockwork of the galaxy turns with a flawless, rhythmic certainty, spinning dust into light and light into life over and over again in the quiet expanse of the dark. Let us drift into a different mode of perception, tuning our senses to the subtle, invisible frequencies that shape this immense stellar nursery. To truly understand the Eagle Nebula, we must look beyond what the eye can see and explore the profound mechanics dictating the temperature, the texture, and even the hypothetical scent of this deep space environment. To grasp the true nature of this space, you might wonder what the Eagle Nebula would actually smell like if you could somehow capture its essence in a jar and safely breathe it in. This is not purely imagination. It is an exercise in applied chemistry. Radio telescopes, specifically the IRAM 30-meter telescope in Spain, have detected complex organic molecules drifting through the colder, denser regions of the dust cloud. Among these discoveries is a compound known as ethyl formate. In terrestrial chemistry, ethyl formate is the precise ester responsible for giving raspberries their sweet, tart flavor, and it is the exact same chemical that gives rum its distinct, rich aroma. Therefore, if you could compress the unimaginably sparse, freezing vacuum of the nebula into a breathable atmosphere, it would carry the faint, sweet scent of berries and aged spirits. It is a strangely comforting realization that the harsh alien depths of space are seasoned with the very same aromatic compounds we find so familiar and pleasant on Earth. The texture of this environment is equally fascinating and deeply deceptive. When looking at the majestic, billowing structures in astronomical photographs, our brains interpret them as thick, viscous materials, perhaps resembling the heavy, rolling fog that settles over a valley at dawn. However, scientists define the interstellar medium not by its density, but by its mean free path. The mean free path is the average distance a single particle travels before it collides with another particle. In the air you are breathing right now, molecules collide billions of times every single second, bouncing off one another in a chaotic, tightly packed swarm. Deep within the core of the pillars of creation, the mean free path is measured in hundreds of thousands of kilometers. A single molecule of hydrogen gas can drift for years, traveling a distance equivalent to the span between the Earth and the Moon, without ever touching another piece of matter. This means the physical texture of the nebula is absolute, perfect nothingness. If you were to pass your hand through the thickest part of the glowing cloud, you would feel absolutely no resistance. It is a grand structural illusion, painted by light and held together by the gentle, whispering force of gravity over timescales we can barely comprehend. We must also explore the profound extremes of temperature defining this region. The Eagle Nebula is a landscape of severe thermal contrast, shaped by the unrelenting energy of the central NG-C 6611 cluster. The surface temperature of the brightest O-type stars in this cluster reaches an astonishing 40,000 Kelvin. At this extreme heat, the starlight shifts far beyond the visible spectrum, radiating primarily in fierce, invisible ultraviolet energy. This ultraviolet radiation travels outward until it strikes the edge of the dark, cold pillars. This boundary, where the intense heat of the stars meets the deep freeze of the dust, is known in astrophysics as an ionization front. You can picture this front as a glowing border, much like the bright, searing edge of a piece of paper as it slowly catches fire. At this precise edge, the gas is flash heated to roughly 10,000 Kelvin, expanding rapidly outward into the surrounding vacuum. Yet, merely a fraction of a light year deeper into the pillar, shielded completely by the thick soot of carbon grains, the temperature plummets to 10 Kelvin. The dust acts as an incredibly efficient cosmic insulator. The cold heart of the pillar is protected from the blazing furnace outside by a thick layer of its own evaporating material. This dramatic thermal difference is the primary engine driving the slow, relentless erosion of the structure. The rapid expansion of the hot gas at the surface creates a pressure wave, pushing back against the cold, dense interior. This gentle, constant squeeze from the outside is called radiation-driven implosion. It is this exact, steady pressure that forces the cold hydrogen molecules tightly enough together to eventually trigger the gravitational collapse necessary for starbirth. The destruction of the pillar's surface is the very mechanism sparking the creation of the stars inside. It is a perfect, elegant loop of physics. What about the sounds of this cosmic nursery? Sound, as we experience it on Earth, is simply a mechanical wave, a vibration traveling through a medium like air or water. Because the Eagle Nebula is a near-perfect vacuum, there is no medium dense enough to carry these acoustic vibrations. The birth of a star, the fierce supersonic winds, the slow evaporation of light years of dust, all of it occurs in absolute flawless silence. However, scientists can translate other types of waves into audio to help us understand the dynamic energy of the region. By taking the data from the Chandra X-ray Observatory, which maps the high-energy emissions of the newborn stars, researchers employ a process called sonification. They assign specific pitches and volumes to the varying intensities of the X-ray light. When translated this way, the Eagle Nebula produces a calming ambient soundscape. The steady, bright emissions of the central cluster create a continuous, resonant hum, while the scattered younger protostars, hidden in the dust, provide soft, rhythmic pulses. The result is a deep, soothing drone, similar to the low vibration of a singing bowl or the distant, steady rumble of a heavy rainstorm. It is a mathematical translation of pure energy, a way to listen to the steady, reliable heartbeat of stellar mechanics. Let us turn our focus to another profound, invisible force shaping this environment: the movement of the galaxy itself. The Eagle Nebula is not sitting still. It is an active participant in the grand rotation of the Milky Way. Our entire galaxy is spinning like a massive, flattened pinwheel. Precise astrometric measurements, utilizing the incredible capabilities of the European Space Agency's Gaia satellite, have tracked the proper motion of the stars within NGC 6611. Gaia measures the microscopic shifts in a star's position over time to calculate its exact trajectory. The data reveals that the entire Eagle Nebula complex is sweeping through the Sagittarius arm at a velocity of roughly 20 kilometers per second, relative to the local standard of rest. Every single element we have explored, the towering pillars, the glowing red hydrogen, the freezing carbon dust, the brilliant young stars, is moving together as a cohesive unit. They are passengers on a gentle, cosmic carousel, completing one full orbit around the supermassive black hole at the center of our galaxy, approximately every 250 million years. This extended time frame is known as a galactic year. Since the oldest stars in this nursery are merely 5.5 million years old, the Eagle Nebula has only completed a tiny fraction of a single galactic orbit since its formation. It is a newborn structure, fresh and vital, just beginning its long, silent journey through the sweeping spiral arms of our home galaxy. As you contemplate this slow, majestic motion, allow your mind to appreciate the flawless reliability of these physical laws. The mean free path guarantees a frictionless, silent environment. The organic compounds quietly assemble in the dark, weaving the scent of berries into the frozen vacuum. The radiation-driven implosion works patiently, century after century, to squeeze the dark dust into brilliant light. There is a deep, unwavering order to this immense space. The universe knows exactly what it is doing, balancing heat and cold, creation and destruction, in a slow, elegant waltz that has repeated flawlessly since the beginning of time. You are floating peacefully within this perfect mathematical certainty, safe in the quiet embrace of the cosmic machinery. Slowly, our observation of this silent celestial theater begins to draw to a close. We have witnessed the towering dust and the blazing light. But to truly appreciate the majesty of the Eagle Nebula, we must understand the precise step-by-step sequence that governs its future. There is a deeply comforting rhythm to the way the universe builds, a gradual unfolding of physical laws that operates with perfect, unhurried certainty. Notice the sequence of events required for a star to finally anchor itself in the dark. The process begins when a specific threshold, known in astrophysics as the gene's mass, is reached. This is the precise mathematical point where the inward pull of gravity finally overcomes the outward push of thermal gas pressure. For a cold molecular cloud hovering around 10 Kelvin, this critical mass is equal to several dozen times the weight of our Sun. Once this exact limit is crossed, the cloud has no choice but to fold inward. Yet, for this gravitational collapse to continue without rebounding, the gathering gas must continuously shed its excess heat. The cloud cools itself through a steady, methodical process. Microscopic carbon monoxide molecules collide in the dark, absorbing the thermal energy of the impact. Almost immediately, the molecule releases that absorbed energy by emitting a photon in the microwave spectrum. These microwave photons slip quietly out into the vacuum, carrying the heat away and allowing the core to grow steadily colder and denser. Simultaneously, a gradual sorting mechanism occurs, known as ambipolar diffusion. Because the magnetic fields we explored earlier only affect charged particles, the neutral hydrogen gas is completely free to move. Over the course of millions of years, these neutral particles slowly slip past the magnetic scaffolding, drifting millimeter by millimeter into the deepest center of the core. It is a cosmic filtration system, patiently separating the matter necessary to build a sun. As the core shrinks, the laws of physics demand a response. Due to the conservation of angular momentum, the collapsing pocket of gas begins to spin faster, much like a dancer pulling their arms inward. This rotation forces the once spherical cloud to gradually flatten into a wide, swirling disk. After roughly 100,000 years of this silent gathering, the infant star transitions into what astronomers classify as a T-Tauri phase. At this precise stage, the protostar is not yet fusing hydrogen, but it becomes intensely active, generating powerful magnetic fields that forcefully blow away the remaining envelope of obscuring dust. It is the moment the star finally clears its immediate surroundings, stepping out from the shadows to shine clearly in the void. This sequence will produce a variety of stars, each with a predetermined destiny based entirely on its starting mass. While the massive O-type stars will burn out in a few million years, the vast majority of the stars born in the Eagle Nebula will be tiny, cool M-type dwarfs, commonly known as red dwarfs. Because they sip their hydrogen fuel so slowly, these small stars will continue to burn for up to 1 trillion years. They are the ultimate marathon runners of the cosmos, guaranteeing that the light born in this nursery will outlast almost everything else in the galaxy. Eventually, the majestic pillars themselves will disappear. Based on the current rate of photoevaporation driven by the young star cluster, astrophysicists calculate that the dense columns of dust will be entirely dispersed into the interstellar medium in exactly 3 million years. The structure will slowly dissolve, sweeping its enriched materials into the broader galaxy to seed entirely new realms. Reflect on the journey of the light delivering this sequence to us. The photons bouncing off the dust and radiating from the glowing gas travel at an absolute unwavering speed of 299,792 kilometers per second. Because the Eagle Nebula is located 7,000 light-years away, the light reaching our telescopes tonight physically left the nebula exactly 7,000 years ago. Consider what this means in the timeline of our world. Those specific packets of light began their silent trek across the dark vacuum around the year 5000 BCE, during the Neolithic period of human history, long before the first pyramids were raised or written language was invented. They have been traveling steadily through the void for millennia, arriving at Earth at this exact moment to be perceived by you. The connection between your physical body and this ancient light is not merely poetic, it is an absolute scientific reality. Step by step, the elements required to build human biology were manufactured in processes identical to those unfolding in the Eagle Nebula. Examine the composition of your own form. Approximately 65% of your body mass is oxygen. This is the exact same element that glows a brilliant teal when energized in the depths of space. Roughly 18% of your body is composed of carbon, the same material making up the microscopic soot of the pillars. Every single atom of that carbon was forged deep inside the core of an ancient red giant star through a sequence called the triple alpha process, where 3 helium nuclei are fused together under unimaginable pressure. The calcium that provides the rigid, sturdy architecture of your skeleton was built step by step through the alpha process, where heavy stars continuously add helium nuclei to lighter elements. Furthermore, the human body contains approximately 4 grams of iron, primarily housed within your red blood cells to transport oxygen. Every microscopic particle of that iron was created in the final chaotic milliseconds of a Type II supernova's core collapse. You are, quite literally, a walking, breathing collection of repurposed stellar material. Even the way you perceive the world is intimately tied to the stars. The human retina is lined with specialized photoreceptor cells called rods, which are responsible for our vision in low-light environments. Biological studies show that these rod cells have a peak sensitivity to light at exactly 498 nanometers. This measurement perfectly aligns with the 500.7 nanometer wavelength emitted by the doubly ionized oxygen in nebulae. Through millions of years of evolution, your eyes were biologically tuned to perceive the exact frequencies of light radiating from the cosmic clouds. You were built to see the universe. As we prepare to leave the grand, sweeping arms of the Milky Way and return to the immediate warmth of your resting environment, allow your body to initiate its own gradual, step-by-step sequence of shutdown. The biological rhythms are functioning beautifully. As the ambient light of your room fades, a small pinecone-shaped structure in your brain called the pineal gland begins to actively synthesize melatonin. Note the elegance of this microscopic chemistry. Melatonin is a highly specific molecule, categorized chemically as C13, H16N2O2. It is constructed entirely from 13 carbon atoms, 16 hydrogen atoms, 2 nitrogen atoms, and 2 oxygen atoms. The signal bringing you peace tonight is built from the exact raw materials suspended in the Eagle Nebula. To initiate the physical state of sleep, your biological clock naturally lowers your core body temperature by approximately 1 to 2 degrees Fahrenheit. This subtle thermal shift closely mirrors the necessary cooling of the interstellar clouds. A gentle reduction of energy, signaling that it is time to collapse into rest. Your heart rate slowly settles, finding a rhythmic, predictable cadence of roughly 60 beats per minute. Your respiration matches this peaceful decline, leveling out to a slow, methodical exchange of oxygen. Within the architecture of your brain, the electrical impulses shift their frequency. The waking beta waves gradually give way, gracefully stepping down into delta waves, which oscillate smoothly and deeply between 0.5 and 4 Hz. It is the slow, rolling frequency of profound physical restoration. Permit the stillness of the room to hold you, just as the silent vacuum of space holds the drifting stars. There is no urgency. The universe operates on a scale of millions of years, granting you the absolute permission to release the minor anxieties of the day. The elements within you are ancient, durable, and perfectly designed to repair and restore cellular balance throughout the night. I am completely safe in this moment. My body knows exactly how to rest. I am made of ancient, enduring stardust. The gravity of the earth holds me securely. My breathing is a slow, steady tide. The temperature of my body is perfectly calibrated for rest. My mind is quiet, reflecting the endless peace of the cosmic void. The carbon and oxygen within me are settling into harmony. Every cell in my body is completely relaxed. I surrender to the slow, gentle rotation of the night. I am connected to the vast, silent beauty of the universe. I release all tension into the comforting dark. I am drifting gracefully into absolute stillness. My heartbeat is a calm, steady rhythm. The silence around me is protective and warm. I allow the deep sleep of the cosmos to wash over me. I am at peace. I am resting entirely. Good night.